Um, Hello, everybody. I'm Larry Lucas, uh, Colorado Main Street architect, and I want to talk today about building energy performance, kind of at a big picture level, and then a few general things, and then some specifics. So here's my contact information. If you want to note that now, I'm always available for questions. Uh,
Larry, you're not sharing anything. Did you mean to share a screen?
oh, I should have. Yeah, let me do that. I can. I need to actually, Tracy. I need to send a request there.
That should be working now.
Okay, cool. Oh, is that working?
It is now.
Okay, cool. All right. Well, sorry about the false start. So today, kind of in preparation for Earth Day on the 22nd, we wanted to do a webinar, talking about the Earth and talking about what we can do in our part on Main Street to essentially, help the environment through saving energy in our buildings. Larry Lucas. Here's my contact information. Go ahead and note this down. You can call me. You can email me anytime. This is something I have a lot of passion for ever since being a Main Street architect. Over a decade ago, starting out, I've always had a passion for sustainability. I do feel like there's really an intersection for sustainability and historic um, essentially these places that are already built, reusing them is kind of like the ultimate recycling. Uh, you know, um, they're very durable. They're easy to reuse. And they save energy. We're not tearing something down and having to rebuild it in order to reuse it again and again. So, not only is it about saving the past, but it's also about the future. So, what do we do with these things? How do we treat them as we move forward? And I'll argue, even as we start out, that preservation is also about new technology, and so we'll get into that as we move ahead. So one thing just to think as we start out is that, gosh, all the work that we're doing, you look at the cover of architecture magazines and things like that, and you'll see that most of the covers are glitzy, glamorous new buildings, right? And the thing that you have to realize though is that 99% of the buildings every year, 99 to 97% of the buildings and all the work that's done on buildings is actually to existing buildings. And so that's something we have to keep in mind. And so that's where we can make the biggest impact when we do our work on buildings. And of course, all historic buildings are existing. So we need to keep that in mind too. So let's break that down a little bit further, kind of at the general energy level. Buildings represent 41% of all the energy that's expended in our energy economy here in the United States. 30% is industrial, 29% is transportation, and then 41% is buildings. And then if you look over to the right, you're going to see how in buildings that energy allocation breaks down. Number one, and this is really for the whole U.S., so not just Colorado, but so space heating is 26%, lighting 10%. Refrigeration is 6%. Computers is 2.5%. I mean, gosh, I think it seems like it'd be more than that nowadays. And then other, I'm not sure what that would be. Maybe plug loads and things that are always plugged in. Those are always burning energy, and things like that. So, just so you know that, and also residential is a 22%. So that's kind of important to know. So really, commercial is about half of that. And we do have some pretty large commercial spaces. Large big box things, and of course, our Main Street buildings are a large portion of that, and other historic commercial districts. So one thing to think about here too, and we're going to cover some of the, we're going to get into more of the highlights and some of the more specific things, but I want you guys to understand things from a high point of view too. So most of our commercial buildings, not just the big boxes and things, or the 29% of them were built before 1960. So, those fall well into the realm of historic, over 50 years old. And if we actually do good quality rehabilitation work that involves some energy retrofits or upgrades, we can actually save 27 to 59% of energy, which will lead to reduction in costs of more than 10% of operating expenses. And I would, dare say much more than that if we actually, achieve, the 60% energy savings. And the way I think about this on Main Streets is that actually, in a smaller market, which, at DOLA, we focus on rural Main Street areas. We don't really focus on the Front Range where we're in bigger cities. In smaller rural areas, your rents aren't as high. A dollar's worth a little bit more in a small town. And so when we do an improvement that, like, say, we insulate the roof on a building, which is kind of an expensive improvement, but it's going to cost about the same in a small market as it will in a big city. And so let's say that we save, a dollar per square foot per year of energy for that improvement. I'm just guessing here. But if your rent is $8 per square foot per year versus the $23 per square foot per year in a big city, don't you see that the impact is much greater for that energy improvement that you've done? And so, as we go along, you're going to see that maybe there are some utilities that will help you with incentives and things like that. So let's just really think as we move along that, hey, let's take advantage of all the incentives that we can, especially in our Main Street communities, because they can really pay off in the end. And I'm going to show you some resources as we move along that are just really great. And so, grab a pencil, consider scribbling some of these things down. These are in-depth research papers. This one, Realizing the Energy Efficiency Potential of Small Buildings, was done by a group that did some wonderful work while they were still established as a group under the National Trust for Historic Preservation, called the Preservation Green Lab. And I'll be referencing several of their documents here. But this one essentially is where I got a lot of these numbers that you're seeing here to the left. And again, just, this may be some stuff of interest, and I'll have quite a few of these. So if something, rings a bell, then please note it. Another study was called Measuring the Value. It measured the value of what it would cost environmentally to demolish a building and build a new green building, like, modern, high performance, green, energy efficient building, versus rehabilitating like a Main Street building and making it energy efficient instead. And if you'll look to the right, the type of building that a Main Street building is coined as is called an urban village mixed use. And they did these studies in actually 4 communities. I'm not showing Seattle or Phoenix because the two that we're kind of in between, I think, are Chicago and Portland. So if you can just imagine, it would take between 42 and 80 years for the energy efficient building after we've demolished and wasted all of that embodied energy. So between 42 and 80 years for that new high performance building to pay for its own debt and the energy it's saving year upon year to equal the savings that's immediately available from rehabilitating a Main Street building. So it's already green. You're going to make it even greener. And so there's really no reason why not to consider, first of all, rehabilitating a Main Street building. And so, historic preservation is really, I wouldn't just say it's the original green, it's really the ultimate green, like we just saw. Instead of thinking about things like we've been led to do since post-World War II, where we think, oh, we just crank up the air conditioner to get comfortable, or we crank up the heat. We flip things on its head, and we actually put the active things, the heating and the things that cost energy, cost fossil fuels most of the time. We put those at the top, and we do everything else that we can first in order to lessen that impact. So, site strategies, maybe we block the wind with some evergreen trees, if we have a house out on the prairie or things like that, to lessen the cooling of the winds in the winter. The building form, maybe we actually make it more aerodynamic instead of less aerodynamic. Passive systems, that would be something building you could actually build a house that had 2 stories. So you'd sleep in the upper floor. So you would actually have the heat would rise at night. And then, your active system would, of course, be like your furnace or something like that. Um, also think about preservation as it's reducing demand for land, materials, and it reuses energy, skills, and labor, and of course, recycles the whole building. Energy improvements. We're going to go through this. I'm going to follow this as sort of a guide for the next part of the presentation. This is a poster from Oklahoma Main Street, and it talks about the retrofit process in 3 parts. And essentially, in a nutshell, we want to preserve the character defining features of a historic building, no matter what. And we can do that, and we can do that with new technology to boot. First of all, we need to look at building as an assembly of systems, not just, hey, we need a new furnace. Well, again, let's look at all the parts of the building to see how maybe we could upgrade insulation. Maybe we could tighten up the weather stripping on the windows. All of these things may help us lessen the demand for this, maybe not need as big of a furnace once we've actually made the building more efficient. So in the beginning, we'll audit, we'll figure out what we need to do. Again, like one system impacts the others, and then we prioritize things and we capitalize on the best incentives. So paying attention again to what does the building offer? Well, these historic buildings before they had electricity, in many cases, the way the windows could open. Double hung means you could lower the top or raise the bottom to invite air circulation. High ceilings meant you could stratify the air. You could bring the hot air, let it come to the top, so that in the summers you could, invite cooler breezes across the bottom, and the hot air would kind of get out of the way. Ceiling fans would invite that warmer air to be pushed back down. Of course, that's after electricity. Brick walls they hold the heat in the winter and release it slowly to the interior at night, and then the opposite during the summer. Transom windows allow light to go deeper into the space so that you have, and then reflective ceilings, like the white ceilings that you see, the old tin ceilings, reflect the light further from the transom windows. Retractable awnings, you can use those to block the sun in the summer, but retract them and allow the sun to come in the windows to heat the space in the winter. And then, what are we expecting when we do this kind of work? We're going to, increase the property's value and have better historic authenticity, actually, because we're going to repair those features that are broken, like our windows frozen shut from paint. Well, let's fix that. We're going to have revenue, happier customers, better occupant comfort. We're going to have decreased operating expenses. We're going to actually be helping the environment. We're going to have less greenhouse gas emissions. So, okay, number 1, and this is a three-part approach: improving the operations. So the first thing that you really should do, and a lot of times there are utility incentives for this, it still involves a cost typically, but they'll knock off some money sometimes, is having an energy audit done by a professional. They can come in and they'll do, like the guy in the middle here, he's doing a blower door test, figuring out the air leakage, like how leaky the building is when you pressurize it with your heating system or cooling system if you have one. When it forces air through the building, how much are you leaking? That's important. Air leakage is one of the major contributors to energy loss in a structure. And so figuring that out to start with, and then doing your best to alleviate those gaps in the places that air, around windows, under doors. How can we pack a little more insulation in to slow down air loss? That's one of your biggest goals in any kind of energy retrofit. And a really cool tool, I've never been able to use it myself, honestly. I don't own a commercial building, but if you do, the EPA Portfolio Manager is a great tool for those folks. So what it does is you plug in 12 months worth of data into this free tool, and it will establish, you put in some data about the building. It's totally private. It doesn't share it openly. And it somehow does that on the back end, though. And it will say, well, this building type uses this much energy, and it will compare your property type to others. And it will say, well, on a range for your commercial property type with this usage, you fall within, you're like an 8 out of 10 on energy usage. but you should be like, you can get down to a 4 out of 10 or something like that. Like that's your potential. And then you can actually track, like as you do those upgrades, you could track your bills and you can see how that changes. It's a great tool. So conservation, what can we do here? Occupant behavior is the number one thing. This book, I have it. It's on the right, New Energy from Old Buildings. It's a 1980s publication about saving energy from the National Trust. It's hilarious. It's like turn off lights when not in use, close windows, use curtains when it's too hot. It really says stuff like this. Like there wasn't a lot of technology available, but this stuff makes sense today. And do we do a lot of this stuff? I mean, no, my kids don't. They tend to leave the lights on. I'm the light turner offer guy. And but you know, occupant behavior is a big deal. And in commercial spaces, can we do things? Yes, and we can automate some of these things nowadays. I mean, gosh, I mean, you can even go to a store and get light switches that are smart and light bulbs that are smart and things like that. You can, but you should have some internal policies if you have a business that say, hey, at night, we make sure that the doors are locked, the cellular shades are down to maintain the heat inside the space. We leave, have a security light, but that's it. We make sure the program, there's a programmable thermostat that the set point sets back at night. And BAS, that's a building automated system for your heating and air conditioning type things and other things. Even computers can be integrated into that. So helping with user behavior is something that we can do nowadays too. So it's not just about making sure you remember to turn the lights off, but there's some help nowadays. And then maintenance is the next part of that. So actually being proactive. And then I suggest actually a seasonal maintenance schedule, like this time of year, well, let's make sure that over the winter there wasn't any damage to the bricks, that the mortar is still in good shape. Maybe we get up on the roof once or twice a year to make sure things aren't cracking or splitting at the roofing. Let's check the paint work after the winter because we've had a lot of freezing and thawing and the paint and the caulking expands and contracts. Setting yourself a reminder to look at that at least once a year. And this is a good time to do those things because, this is followed by the building season. So we can actually do some painting and things like that. Fall is, another time to do some things, but typically this is, I think, your prime time to, if you're only going to do it once a year, to kind of check everything. And then, recommissioning equipment. How often, let me just ask you, how often have you checked your home heating and air conditioning equipment to see if it's still running correctly? You ought to have someone come out and look at it and tune it up every few years. It's just a good idea to clean it out and everything around the jets and all the things. It'll actually save you some energy. So the next thing we do is we're going to reduce loads. And this is going to lead up to actually like how to make the building holistically better, which is what we're doing. Number one is lighting. Obviously, and I'm sure you've heard, and not necessarily obviously, but LED lighting is sort of the thing to do. I love it because in the picture to the right, you're going to see that you have choices, and there are reasons for choices and color temperature. Where you may have a swanky jazz lounge with this very warm color temperature, and actually there's even warmer than 3000 K on the far left, that yellowy color. And then the 6500, which is extremely bright white on the very right. You may have the very swanky jazz lounge or something on the right, and then a shop where you need to see like a needle on a countertop or something on the far right, just for very detailed work. They have their own place. And this was on a page for a certain type of a fluorescent fixture. You can see them there, that you could actually toggle between the color temperature that you want. I've got some in my garage that I got at one of the big boxes, and you can actually flip. I think it has 3 selections between color temperature, and I didn't pick the brightest one. I picked the one that was the next lowest one, just because I didn't like the brightest one. And that's really lovely to have that. I don't think you're going to want the brightest one if you have a business or a retail shop. I think you're going to probably be, you may, depending on what you're selling, you may want a little bit more like daylight, like 5,000. If you're doing more of the warm white, like 3,500, you're probably looking at selling like homewares and things like that. Which is the environment that you're going to be viewing those things in. You have to think about that too. So if somebody's going to be, if it's things you're going to sell in the house, think about how you're going to light that when you sell it. Um, so for, there are good utility incentives for lighting. And a good thing you can do, kind of a bonus tip, is that you can add room sensors, and only in situations where you're going to have people in for a short period of time and then out, like a bathroom or something like that. You can get different timers for those. It's not the kind of place where somebody's going to be sitting at a desk for a long time and the light goes off and they have to like wave their arm. Have you ever been in a room like that to get the light to come back on? So use those like maybe a storeroom or something where you're in there to get a pair of shoes and then you come back out. So you don't have to mess with the light switch. And then, task lighting, instead of having to turn on a big light for like the entire back of the house, if you need to go back and work at a little desk after, closing, why not just have a little desk lamp and a little LED desk lamp and use that instead of having every light in the house on? Something that's pretty smart, and I don't have one of these, I'll admit, and I'd like to get one for my computer setup. It's a smart strip, and it actually will automatically shut off all the little, I don't know if you've heard of this, but the little boxes that have the plug in for like your cell phone and for your laptop, the little charging brick. They create what's called a vampire load, and they're always draining some power, even if they're not like, even if your computer's like not technically charging or pulling power at that exact second. If you feel those things, they're always warm. They always have some heat, off coming from them. Well, that's electricity that you're wasting. These will actually switch those off based off of a control outlet. And so, like if you shut off your laptop, I believe it will turn off the ones that are switched. So, like your printer, all the other ones, and it will just kill them. And then there's always on outlets, and there's different varieties of these that you can have, plugs to infinitum. I mean, so that's something to check out, and I think I might do that too, maybe for a couple of key locations around the house. And then you can even go to, I'm sure, some pretty advanced degrees if you're going to rewire a building brand new and get a new panel. There's all kinds of things available. Besides just like arc fault protecting your panels and to keep people safe from instead of like just putting a GFCI or the ones that'll keep you from getting shocked to death by a sink or things like that, you can protect the entire building that way. There are also just there are a variety of different things that you can do to your circuit panel with protecting your data lines and all kinds of different things. Smart home wiring, all of that carries through to commercial wiring now too. Another thing to think about is Energy Star equipment and appliances. Those will save energy. And if you have a choice between the two, look at the specs, see if it's going to run as efficiently. Look at the reviews. The chances are nowadays it will. And, even if it costs a few bucks more, it might be worth doing that to save energy in the long run. So building envelope. This is a place that we're going to actually, we're looking at saving the big bucks. Again, like I was saying, leaky buildings it's a big culprit of our energy. Now with historic buildings, that's a challenge because, we often can't disrupt windows and, glazing, like big storefronts, and, roofing is challenging because it's a big surface, and like, well, how do we do these things? Well, let's start off with doing the simple things like we talked about, in a town, a smaller town, where a building might not command a very high rent price. Let's go after the free stuff, or for that matter, anywhere. Let's go after the free stuff first and see if there's any kind of weather strips and things like that we can get from our utility. I received some things from Excel at one point when we moved into our home that had a little weatherization kit. It was just a little box. It didn't have a ton in it, but it was enough to like weather strip a couple of doors. And um, I think they wanted to give me a thermostat, but they were going to track my use and switch things off. And we did something a little differently with our own programmable thermostat, which I think is actually better. But there are things available that can save you energy for free. Just consider taking them up on that. Another thing to think about, and it doesn't actually show it in this diagram of this cutaway diagram on the right, but a lot of times above there is a ceiling that's below the roof in your upper floor. And not all buildings are 3 stories tall. I realize that. So just imagine if it's 1 stories that you just kind of put your hand over the bottom two. There's a lot of times there's a ceiling and then there's a space and then there's a roof above that. So if there's a ceiling in your building, like a tin ceiling or whatever, sometimes there's access up there, and you could blow in some cellulose insulation if it looks like it'll support that weight. And adding that insulation to that attic space can be a tremendous saver because often they're just uninsulated. And it's funny, there just wasn't a lot of insulation product when these buildings were built. That's why you'll see like newspapers sealing up air leaks, like plastered to walls in some of these upper floor spaces. Things just stuffed in cavity spaces. I've seen like horsehair things and just matted board and newspaper and wadded up and there's not, and we're going to talk about insulation a little bit in a minute because it's tricky. You can also put storm doors over the outside of, and maybe not over your front of your commercial door in the front, but in the back for your rear entrances. Those actually can save a lot of energy and wear and tear on the door from sunlight and from rain and things like that. Basements and crawl spaces in Colorado, those are a big deal. So like the perimeter, like the walls come down and they sit on a stone foundation typically, or the ground. And then there's a beam that carries the floor joist that goes around the bottom, and the floor joist rests into that beam or on that beam. That is almost always uninsulated. And if you can get in there and insulate under the floor in that beam or in the spaces between the floor joists, that's great. And then it's dirt a lot of times underneath that if it's a crawl space. There are ways to insulate those. They get tricky. So if all you can do is insulate that rim joist around the bottom, that will save some energy. If it's a basement, there are ways to insulate basement walls. You typically lose energy just like a sieve through a basement because the ground temperature is around 50 degrees, and if you're trying to heat your interior to 65 or whatever, it's a constant energy drain. So there is a point of diminishing returns on that. It's worth investigation, and then those energy professionals or myself, I could actually help you investigate that. Seal and insulate ducts and pipes. I mean, if you're going to blow warm air, you want it to get to where it's going. So make sure that your ductwork is in good shape. And then your pipe insulation for hot water. If you're running that up into that attic space and across a cold, freezing cold attic, and then down into a bathroom and an upper floor, or even a single story, doesn't it make sense to make sure that that's wrapped in some insulation so that you're not just heating the attic with your pipe and wasting that energy. And then awnings and shading devices, sometimes those are really helpful. Okay, so just real quick on insulation. This is a masonry wall on the right, and we're showing some insulation in yellow here. And then essentially the interior air. Of course, there'd be some kind of, you really can't insulate an interior because there's usually some stucco or something over the brick if it's finished directly to the brick. So I hate to say it, but you're kind of stuck with that. And I think that's fine. Again, the brick has some thermal mass. And so, it's not like you're just dealing with a wood framed house that has no insulation. There's a thermal lag. So, as you heat the interior in the winter, it slowly moves to the outside. And then, of course, you do get some sunlight coming in. And the good news is most buildings on Main Street share a wall with another building. So you're not gaining or losing energy between buildings. And that's most of your wall area. You only have a little front and a little back. And then most of your walls are these long walls between buildings. So, it's not a huge concern on this part. But now the roof is a good way to save some energy. But back to insulating. So if you're insulating anything that's masonry is tricky in Colorado because let's say that you do want to insulate a back room or something, a really leaky back room. Nobody's going to see it. It's very cold back there. So you frame a 2x4 wall and you want to insulate that. You want to use some you don't want to use any kind of spray foams or anything. You'd want to use an insulation that would allow water vapor that's carried in the warm air because we all transpire warm air from our breath. We want and warm tries to move towards cold, as you'll see in this diagram. Now, the thing we have to be most careful with is that even through drywall, it will move through drywall slowly. That warm, moist air will start to get colder until it reaches a dew point temperature when it turns and condenses into water. And we don't want that to happen inside of our space. We want that to happen in the middle of the brick, ideally, because brick will tend to dry to the outside. That does pose another problem because brick can actually freeze towards the outside and it breaks the faces of the brick, especially if it's painted and it can't completely dry out. So it's very complicated. And that's why I'm here. Can you insulate masonry? Yes, you can, but it depends. And there are other special vapor barriers that you can put on if you're going to do this. And there are situations that you may want to do this, usually during a remodel. But all that said, if it's a wood frame, yes, you can absolutely insulate. There are good standards to do that. Replacing windows, we're going to touch on that here in just a second. Let's just move on to that now. And any questions, please follow up with me directly and we'll work on it. So I just want to show here that this study done again by the Preservation Green Lab, and there's a lot of information in this. It is well worth flipping through it. It's pretty in depth and it gets very technical. But I just want to show you essentially where it says the second main column breakdown where it says thermal performance. It has U factor and then solar heat gain coefficient, SHGC. I just want to show you that if you put an exterior or an interior storm window, which I'm always a fan of the interior storm windows, because you can pop those dudes out during periods of nice weather and open your windows really easily. But the exterior ones just don't look great because they're usually those aluminum things that that were kind of on your grandparents' house, and they had them in the 70s. They can also get them in wood, but they're super expensive and they're just like maintaining a wood window. In any case, they both save a lot of energy. And if you'll look at the numbers on the low side, where it says low value, and compare it to the new high performance replacement window, they're like so close. And the reason why is because you're creating a big airspace, and air is your ultimate insulator. So, if you imagine, the depth of your window jamb on the inside, you've got a few inches there. So even if you like install your interior storm window, which a lot of times they're just friction fit into the window, into the jamb, it's just like a neoprene gasket with a plastic sheet and a couple of handles, and you just friction fit those in. And they make them custom, and you just friction fit them in. And like in the winter when you may want them to buffer some of that cold, and it creates, a certain R value per inch for that airspace. And to me, it's just amazing that you don't need to do a lot else to equal the equivalent, at least, heat transfer wise, of a brand new, super efficient triple pane window. And this study proved that conclusively. And then really the payback. Let's look at that. Because I mean, windows are such a big deal. And I'll tell you, I think windows are the big deal because people just think it's easy. It's like a lot of times developers are like, let's just scrape that building and build a new one. It's because it's easy in their mind. They don't want to wrap their mind around the, redeveloping something. They think, oh, I can just have my architect or whoever, I can I have a plan. I just want it to be this way. It's easy for my brain to function this way. Same thing with replacement windows. They're like, I know what it is. I know what I'm getting. I know that it's really fast and cheap. I can do it this way. I don't have to get a specialist to come take the window out, take it to a shop, reglaze it, bring it back, put it in place carefully. I mean, that is the process with the historic window. Typically, they rebuild them because they've most typically because they've been painted over and over again and not cared for. Sometimes Sometimes they have been, though. Sometimes it's been covered up with a layer of plaster or exterior stucco or some of those metal slip covers that are just covering the whole facade. And you have these wonderful windows that are just ready to go. So you never know what you're going to get. But here's again a picture. If you're on the far left, it's a storm window over a single pane window right here. And we talked about how much energy that can save. It will pay for itself in 4.5 years. But if you go all the way over to the right, low E glass, double pane thermal replacement window of a single pane window, it takes 240 years for the energy savings to pay for that window. That's just pretty crazy to think about something being so convenient that it's worth that much, that it being that cheap is that good. To me, I think our legacy that we leave for the next generation is worth more than PVC, so why not keep something authentic instead of, leaving somebody something else in the landfill in another 15 years. So upgrading systems, this is the last thing we do. After we've made the building, we've improved the operations. Next thing we've done is we've reduced the loads on the building. Now we want to upgrade systems. It's the last thing we're going to do because, we don't just come in and slam in a bigger furnace because the building's cold. We think about this as a holistic system. And the last thing we're going to do is we're going to come in and we're going to put in maybe a smaller furnace now. Hey, we're going to burn less gas. Or we're going to use less solar energy to use it for our solar heat pumps. So HVAC. First of all, I'm not condoning this effort on the right. I wanted to show you this. Not mainly because you can do duct work that's not hidden above ceilings. You can see how this is the kind of what you see a lot of times when you see a remodel in a Main Street building. You can see on the left the green paint. They had lowered the ceiling very obviously in this structure and they had duct work that was just run of the mill. You want to hide it above the ceiling. These guys are saying, look, we can do spiral duct that's pretty good looking, and and we can get you your tin ceiling look back. Now, would I have run it in this manner? No. I would have put it against a sidewall and I would have run my branch ducts out from there just so I could see more of the tin ceiling because it is beautiful. And it's just, and I would have focused more on how the lighting fixtures were laid out and how those kind of gave some order to the space instead of this, because these things are hideous. But so the idea is good, but could have been implemented a little better. But you'll see this a lot. A lot of times you'll see these low ceilings, and the reason they lowered the ceilings is because they needed to put duct work in, and they wanted to put fluorescent light fixtures in that fit into those suspended ceilings sometimes. And the only way to do that would be to put in a lower ceiling. So that's why I wanted to show you that one. So a lot of times you can actually get that energy audit that we were talking about up front. It may cost you a few bucks. They'll come out to your business and look at it. They'll let you know like how old your equipment is. And sometimes it'll say on there, sometimes the guy that installed it or girl, they might have written in a Sharpie, like when they installed this system. That's, it's good to know. And then you may get a free tune-up out of the deal. Again, if you have awnings, let's think about, maybe it's a good time to to clean them in the winter. If it's not a terrible frame, you could leave them off. You could, if it's retractable, you could bring them up. You could also work with me and we could figure out the correct depth from the building to put the awning so that you get the sun rays in the winter because the sun's at a lower angle, and then still have the awning to protect you from the higher angle rays in the summer. And then, so, with reduced loads, you can downsize and maybe even upgrade to something like a two-stage furnace for the winter. So a two-stage furnace is kind of based on an 80-20 principle because you don't need something that just comes on, boom, full force every time it comes on. I mean, my home system does this. It doesn't matter if it needs to be on for 3 minutes to get back to the set point or 20 minutes because I just came home and turned it on for the first time and it's been off for 2 days. A two-stage furnace kind of works and it says, well, about 80% of the time it needs to be on the low setting because it's just it's not freezing cold in the building. So it stays on this lower setting where it's burning less gas and it's operating the fan at a slower speed. So it's actually quieter, more comfortable. It allows the filtration, I believe, to work a little better and just more of a soothing kind of an air. And then whenever you really need to ramp it up, it will kick on automatically. And that's like 20% of the time from what I was reading about it. So, investing a little bit more money, which they are more expensive, but, for more comfort and spending less money on fuel, it's kind of like it's like taking off fast from stoplights all the time. That going really fast off the stoplight burns more gas, right? So it's kind of the same thing. To go with the two-stage is better than just blasting every time when you start up. And then hot water. Hey, if you just have if you're in retail and you're selling clothing or something, and you have a bathroom, get one of these little guys, one of these little electric under sink hot water heaters, and set it to the temperature that's comfortable for you to wash your hands, and get rid of the water tank. You don't need to store hot water because those water tanks, again, they're just losing heat all day. You can get a blanket for your water tank that will help it slow that heat loss. But still, why are we holding water that we're maybe not using? Now, if we're doing like loads of laundry, or we're doing dishwasher loads and things like that, kind of on a semi-regular basis, and we need that load, then it makes sense to actually hold a load's worth in a tank. Or we're taking a shower, then it makes sense to actually have a small tank. In homes, you have somebody on a shower, washing dishes and doing clothes sometimes at one time. That's why you have a certain size tank. But in a business, that's not going to be the case typically. So keeping it simple with these is a good idea. Again, there may be incentives for some things. It really varies a lot. I don't know much about utility incentives around the state. It's kind of my fault, but if you know about some good ones or find some good ones, please let me know. And then renewable power. I don't know the status of the tax credit right now, the 30% tax credit. I wish I did. But I still know that solar energy is pretty awesome. You're getting free energy from the sun. What I have heard is that it's hard to make it, at least again, back to my own experience on my own home. The folks that come around and knock on the door, they want to install it. They want to get they were wanting the tax credit and so on. In order for those to pencil, it's going to be 20 years. And by that point, the panels are going to be dated and all of that. What I've come up with is that if I was ever to do that, I would have to be a little bit of a handyman or know somebody that would do it for a reasonable rate. I would go to Costco and I would purchase my panels through Costco and get the Costco bucks or whatever they call them. And I would go to like Vectra Bank or somebody like that does energy loans, and I would use them potentially to help me with any extra money that I needed to purchase them. And then I would hire someone like an electrician to do the wiring and the panel setup for it. And in the end, it's not being fronted to me like one of these guys that knocks on the door. but I own it for a much lower cost. And then I actually start generating, I'll start paying off the loan um, much faster. Like it'll start paying for itself much faster. And of course, there's the Colorado Clean Energy Fund, and I do believe they do things. I want to say they do things for homeowners, but I also have heard of Vectra Bank too. If you're gonna use this for your business, though, you might think if you have like refrigeration, if you have a pharmacy, you have medicines that are expensive, you need a battery backup if you're going to be on solar power, and you may need a battery backup anyway. You probably already have one, but that might be a need you have. And then other guidance. Let's just touch on this real quick because definitely, at Colorado Main Street, we're not the ultimate authority on this. This is part of a broader field of something called building science. And building science is essentially dealing with the way buildings operate, and mostly including the mechanical engineering of buildings, which is essentially the mechanical systems, the plumbing, the heating, the air conditioning, and those things, not the structure, not the structural things, and not necessarily the architectural things like bricks and glass and things. Although building science does take into account, this is a big word, high growth thermal analysis. So, like how moisture moves through bricks and wood and insulation and things like that. So that's a whole school of thought. Kind of touching on this from a couple angles, though, the National Park Service has these wonderful assets. The preservation brief number 3 about improving energy efficiency in historic buildings is a nice read. All the preservation briefs, I think there's 51 of them, are really nice on a variety of topics dealing with historic buildings, many of them relevant to Main Street buildings. And then another nice guide is this illustrated set of guidelines for sustainability. And it's cool because you flip through this, it's like a landscape formatted book, and it'll say, do this, not this, when you're talking about roofing, or do this, not this, when you're talking about windows. So it's great. It's available online and it works just great. It's like an interactive web page. And then, so talking about building science, these are the gurus right here, the American Society of Heating, Refrigeration, and Air Conditioning Engineers. And we have this in our library. If anybody wants info, you get zero off the internet about this. You have to purchase this. And it's a little booklet right here, but it's great because they actually reference the Secretary of the Interior standards. It's a great resource, and it gets down to the nitty gritty of the things you need to do for like water storage and just everything. So let me know if you have any specific questions about how to do this kind of work in general or specifically. How to keep a building historic in nature, is maintain its character defining features, and run a duct to a weird position or something like that. There are allowances, and there is flexibility in the Secretary standards for rehabilitation to be able to do this kind of work in order to allow it to be adapted to be continually used as a commercial property. That's the intent of those standards, actually, too. So there is flexibility. Let's talk about the new codes. So in 2023, the state law became that anytime a new code, any kind of code, new code is adopted in a municipality in Colorado, they had to adopt at minimum the 2021 International Energy Conservation Code. So essentially, every municipality in Colorado, and I think this is the only, there are maybe a fire code. This is the only building code that I know of that is mandated that municipalities have to adopt. Pretty interesting, very progressive. I would imagine somebody like California might have this, but what this is going to mean in the long run is that our buildings will have to be reviewed to meet minimum standards. These aren't like shooting for the moon. these are just, and these are things you can buy at Home Depot, like the types of insulation are available. These are not like way out in la la land type products. These are, but it also means things are done to a certain specification, that they're not just being sloppily constructed when they do a remodel. I mean, second bullet or third, there is a grant to actually help municipalities adopt this. I'm set on the board or the selection committee for that. It actually helps with the adoption process and also the enforcement. So it also will help with paying for a period of time for communities to review applications. And then generally with the building code for energy, you only have to modify things in historic buildings that you touch. Like if you touch the air conditioning system and the ductwork, there's a good chance you need to update the area of that modification, like that room. It generally won't be the whole system. Some things apply. If you just change one window, you won't have to do all of them. There is a threshold you cross where you would if you are modifying most of the building. And then there's also historic exceptions that if it's going to alter the character defining feature of a building, then you don't have to update it. So there's a way out of a lot of things for historic stuff. Again, glad to talk about that. I'm always available. That's just essentially what I'm saying here. Glad to help with any kinds of your projects. We have a resource online, essentially like how to fund this type of work. And Tracy and I are glad to share this with you guys. This is essentially the strategy in a nutshell. I'm not going to go through it, but it involves utilizing the tax credits and leveraging those to pay down loans that you get that are low interest loans through the Clean Energy Fund for commercial loans, for business loans, and then being able to re-amortize that once you get your tax credits sold to lower your monthly payment. And then all those energy improvements will essentially offset your monthly payment even more. So you end up with very little out of pocket per month. And then, just remember that really our planet is not just ours, it's for the next generation too. And I appreciate your time and thanks for being here today. And just if there's any questions, I'm glad to take them.